Hello everyone, and a warm welcome to the sky this month for February 2022. My name's Paul Martinaitis, and I'm a member of the Astronomical Society of South Australia, or ASA for short. So in this show, as usual, I'm going to try and give you a good overview of some of the key events and interesting things to look for this month from the Southern Hemisphere. So we'll begin with a general overview of the sky. We'll then move closer to home and look at the moon and when are some good times to observe deep sky objects and lunar observation and so forth. We'll then look at a lunar feature of the month and finish off by looking at a deep sky object, one that will be very good if you can get yourself to a dark sky. So let's take a look at the sky for February 2022. So this shows you the sky on the 1st of the month, the 1st of February, at around 10 p.m. So that's about half an hour after astronomical twilight here in Adelaide. So as usual, we'll begin in the west. So these are the constellations that will set first. So if we want to view any objects in this region of the sky, we'll want to do it early in our session. So we can see that Grus is now pretty much touching the horizon at the beginning of the evening. So really, it's too late to look at any objects in that constellation. I would wait until much later in the year when it starts to rise nice and high again. Sculptor and Cetus, however, they're a little bit higher. So if you want to look at some of the objects in them, certainly you can do so. But like I said, I would do that earlier in the evening. Looking a bit higher though, we can see that object constellations such as Tucana, Phoenix and Fornax, they're still quite high, so they're well placed for viewing at the moment. And of course we have Eridanus dominating this part of the sky as well, the second longest constellation that winds all the way from Orion towards the north, all the way across the sky towards the south, and it finishes with the relatively bright star Arcana in the south. Okay, let's take now a look at the northern sky. So summer, of course, is well underway, dominated by the great constellations of Orion and Canis Major. In fact, Canis Major is pretty much straight above now at this time of year. A bit lower down, we have Taurus, which is now quite a bit higher than last month. Gemini is also becoming higher as well. And we can see that the two brightest stars in Gemini will become quite prominent. Castor and Pollux, the name of the two Gemini twins. So just moving up here a little bit. There's some very bright stars around at this time of year, in particular Sirius, which of course is the brightest star in the sky, also one of the closest at about 7 light years away. And that forms a triangle with the supergiant Betelgeuse and the Procyon, the brightest star in Canis Minor. Another nice object that I might just point out while we're here is M79 in Lepus. So Lepus is quite a bright constellation, and it sits above Orion, and it has this kind of pinched rectangle sort of pattern. And if you look at the top of Lepus here, you can imagine the M79. If I join a line from this star to M79 and a line from that star to M79, you can see that it forms kind of like a diamond shape. So essentially, if you look at this line, these lines here, and if you make a symmetrical set of lines here to form a diamond, it makes M79 very easy to locate. And I'll also put up a Telrad circle. So if you have a Telrad on your telescope, if you place the outer ring of the Telrad on that star there, I'll zoom out a bit, in Lepus, M79 will be on the other side of that large ring. And then what you can do is you can just simply move your telescope like that. using the rings as a gauge to how far you're moving. And what you'll be rewarded with is a nice globular cluster, not as big as something like 47 Tuc or Omega Centauri, and not as bright, but it's still relatively bright, and it's nice and compact, and it still resolves once you apply a bit of magnification to it. Okay, so now we'll take a look towards the east. So these are the constellations that are now rising and becoming higher and higher. So we saw Eridanus before, a very long constellation. Here is the longest constellation in the sky, Hydra. And we can see that quite a bit of it is now appearing above the horizon, but it's so long that some of it's still below. So there's a lot of really nice objects in Hydra, some planetaries and also lots of galaxies. So in the coming months, as that gets higher in the sky, that's something that you will definitely want to look at. Speaking of galaxies, most of you would be familiar with Leo and a lot of the nice galaxies in there. So Leo is just poking its head above the horizon at the moment, and of course again that will become higher and higher as the month progresses. Okay, so looking south now, things have changed, moved on a tiny bit from last month for this time of the evening. So remember the South Celestial Pole. If we want to kind of estimate where that is, we've got Acrux in the Southern Cross, the brightest star here. If we draw an imaginary line all the way to Arcanar, and about halfway along that line, so about here, that's where we'd find the celestial pole. So that's the imaginary point about which the sky appears to rotate for us. So you can see that the Large Magellanic Cloud is pretty much the highest it's going to get. So excellent time of year to be viewing in that region of the sky. So last month I talked about the Tarantula Nebula, which is probably the most obvious object when you take a look at this galaxy. But there's a lot of other fine objects in here as well. So have a scan of it with your binoculars or telescope. Well worthwhile. Some other constellation as well, such as Reticulum and Horologium and Dorado. They're now very high in the sky as well, so very well placed for observing the many fine galaxies in particular in this region of the sky. Okay, let's now take a look at the lunar calendar for this month. So there's the calendar of the lunar phases. So as usual, I've highlighted in blue the regions of the month where the moon won't interfere. So that's from the 1st of February through to about the 5th or the 6th, depending on how late you want to stay up. And then near the end of the month, from the 25th through to the 28th, and then spilling over into March. They're the times that you'll want to reserve for observing deep sky objects, hopefully from a dark site. So things like galaxies, fainter nebula, planetary nebula, and so on. And in the middle of the month, from about the 6th through to the 24th, that's where the moonlight will interfere. So that's the time where you're best reserving for things like observing the moon itself, double stars, star clusters, and perhaps some of the brighter nebula like the Orion Nebula and so forth. So near the beginning of the month, you can see that as the year's progressing, we can begin our observation sessions a little bit earlier. So from Adelaide, darkness begins at the beginning of the month at around 21:50, ending at around 5 a.m. And then by the end of the month, we can start about half an hour earlier at around 20 past 9, and darkness will end at about 5:40 or so. So the nights are starting to get gradually longer and start a bit earlier, which is nice. So in terms of the lunar phases, new moon is on the 1st of February, right at the beginning. First quarter is on the 8th of February. Excuse me. Full moon is on the 17th. and last quarter is on the 24th. Okay, so we're now going to take a look at the lunar feature for the month. So you might recall that last month we took a look at Mare Crisium on the near the eastern limb of the moon, and that was a fairly circular, self-contained sea on the eastern limb of the moon. So this month we're going to take a look on the opposite side towards the west at Mare Humorum, or the Sea of Moisture, and that's also has a fairly round circular shape and self-contained from the surrounding mare. So it was originally formed like Mare Crisium via a basin impact. So basins are the largest impact structures on the moon, formed by very large objects impacting the moon. And when they hit, they cause disruption to a large area of the moon's surface. And coming away from the center of that impact were concentric rings formed by the rippling of the ground as a result of the impact. So today these ripples are very, very hard to see because the impacts themselves occurred very early in the moon's history. So in the case of Mare Humorum, the impact occurred about 4 billion years ago. And then subsequently, of course, lava has flooded the region, forming the mare that we see. Impact craters have been overlaid on top, smaller ones. So the remnants of those ripples can be quite hard to see. But some of them are still sometimes visible. So for example, in this close-up picture that you can see there, those dashed yellow lines indicate the remnants of those concentric rings. So the outermost one you can see sort of starts near the crater Billy and then proceeds south. There's a very slight, very enhancement, like a little tiny mountain range along that dashed line, and it kind of terminates with Mercenus. And then you can also see part of the inner ring, which starts at the crater Gescendi. And then to the right of that yellow dashed line, you can see that step-like structure in the mare surface, and that is one of the inner rings formed by the impact basin. So we'll now take an even closer look and look at some of the key features surrounding Mare Humorum. And one of the striking things you notice when you look through a telescope is the mare floor, which consists of basalts or solidified lava. There's quite a few different shades and colours in that, and that's because different lavas flowed at different times, and they had therefore different compositions. And that then corresponds often to different colours, sometimes in UV light and infrared light, but also sometimes in visual light. So in particular, if you look on the eastern side there, that patch there labelled EHB, or Eastern Humorium Basalt, that's readily apparent in the telescope as a darker region. Towards the bottom, there's that lighter sort of formation called WHB, or Western Humorium Basalt, and then the rest is called CHB, or Central Humorium Basalt. Another particularly prominent patch is actually called the helmet, so you can see that labelled up there towards the top right, and it actually looks like one of those upside down old army helmets. And that's a bright patch of some material, possibly a different type of basalt, or even the remnants of some destroyed craters. And that's extremely prominent as well, even through a small telescope. And another feature surrounding the crater of Dunthorne is you can see it kind of forms this diamond, quite a distinctive squarish looking diamond plateau, which is very interesting again to look at. So let's now take a look at some of the major craters. So the first crater we're going to look at is Gescendi, that one at the top. Um, and one thing you notice as soon as you look at Gescendi is it's quite shallow. So normally an impact crater of that size, it would appear a little bit deeper, and it would have a central peak in the middle, which is formed because after the impact there's an upwelling or a rebound effect which forms a central peak. So Gescendi is quite a bit shallower, and it has kind of ruined peaks in the middle, and you'll notice the rim facing Mare Humorum towards the bottom is very thin, almost swallowed by the lava. And the reason for that is because when you think about it, it's logical that the slopes, the slope of the basin would be sloped towards the center, because it is, after all, a very large crater. And then after the impact basin was formed, another smaller impactor formed Gescendi. And you can see that by its age. The Humorum impact occurred about 3.9 billion years ago. The age of Gescendi is anything from 3.85 through to 3.2 billion years. So it happened relatively soon after that impact. And so Gescendi would have been formed on that slope. And then quite a bit later on, the lava started to flood the region. So naturally, the lava would inundate the lowest side of the crater first, which is the side that faces the Mare. And you can see that there, particularly in that close-up. And also through the telescope, another feature you'll notice is some of those riles or grooves that you can see. They look like cracks in that photo. So with good seeing, you can see some of those through a telescope. And those cracks are where some of the lava emerged that flooded that crater as well. And on the top part of Gescendi, you can see another crater called Gescendi A. And just by looking at the geometric situation, often when you're looking at craters on the moon, you can kind of infer which one's older than the other. So you can see clearly that Gescendi A came afterwards because it kind of flattened the bit of the rim that it hit. And in fact, you can see by the age there that Gescendi A is a lot younger, at 1.1 billion years. So it happened a good 2 billion years after Gescendi was formed. Okay, let's now take a look at the solar system. So we'll begin by taking a look at the inner planets. So during January, Mercury and Venus were evening objects. Towards the end of the month, they went into conjunction. So they were between the Earth and the Sun, and therefore unobservable. And so you can now see at the end of January, which is kind of shown here, moving into the beginning of February, both Mercury and Venus start to move away from the Sun, and they're becoming morning objects again. So at the beginning of February, they're quite close, still very hard to observe, but as the month progresses, so there's the 10th of February, and then we'll move on to the 17th of February. Both Venus and Mercury become quite nice morning objects. In particular, on the 17th, Mercury has reached what we call greatest elongation. So that means if we draw a line from the Earth to the Sun, and then from the Sun to Mercury, that's at right angles. So that means Mercury is the largest apparent distance from the Sun. So that's a good time to observe the planet. And I'll show you a view of the morning sky after, a simulated view of what that might look like. So you'll need to get up nice and early to observe these planets. And the same applies for Mars as well. We're still quite a distance away from Mars, but we are catching up. So we're heading towards that opposition in, I believe, December, where Mars will be the closest to us for this cycle. And so we'll talk a lot more about observing Mars later on in the year. But for now, even though it's really too small to appreciate any details through the telescope, it still makes a lovely sight in the morning sky. And in fact, if we move towards the end of the month on the 28th, and again, I'll show you a simulated picture of this shortly, you can actually see 4 planets plus the moon. So you'll be able to see Mercury, Venus, Mars, and also Saturn, which has also now emerged from conjunction and is also a morning object as well. So be sure, if it's clear on the 28th February, try and get up nice and early, and if you have and try and get a good view of the eastern sky, and you'll be met by a lovely sight. So let's now just move out and have a look at the outer planets. So we've already mentioned Saturn is a morning object. The other planets, there's not a lot going on at the moment. Jupiter is in conjunction with the Sun, so the Sun's between us and Jupiter, so it's not observable. Same really applies to Neptune. That's sort of moving into conjunction as well. So the only other outer planet that we might choose to observe is Uranus, and that's an early evening object, and soon that'll be lost in the twilight as well. So really, the action is all on the inner planets. Most of the outer planets will have to wait until later in the year to observe properly. So I mentioned before that Mercury reaches greatest elongation on the 17th of February. So this shows you the eastern view of the sky from Adelaide at around 5:45 a.m. So you'll see Venus, of course, will be the brightest thing in the sky pretty much. Close to that, you will see Mars a little bit off to the right, and then somewhat down and towards the right, you should see Mercury as well. So a lovely naked eye sight. If you have binoculars or a telescope, be sure to take a look at them, because although you won't see surface features, or very unlikely to see surface features, I think, you will certainly see the phases in these two planets, particularly Venus. But Venus, you can actually see the phase through binoculars. I find to see it properly, I need to steady it by resting my hands on an object or using a tripod. Certainly through the telescope, you'll see it. So it'll be a nice sort of crescent shape shown there. And Mercury will be more of a gibbous sort of crescent as well. So be sure, if you've got your telescope or binoculars out, to take a look at those two planets. And you might as well point your telescope at Mars as well while you're at it. It's still a long way away. I doubt whether you'll see any surface features on it at this stage, but why not give it a shot? You never know. And here's the 28th of February, so right at the end of the month. Says it's at about 6 a.m. So you can see here you've actually got 4 planets. You've got Venus, Mars, Venus and Mars even closer together now. You've got a real slender crescent moon. Below the moon you'll have Mercury, and then below Mercury you'll have Saturn as well. So that's certainly a sight worth getting up for. Okay, so the deep sky object for the month is one of my favourites, the Rosette Nebula in Monoceros. So we're discussing Monoceros earlier in the presentation. Very faint constellation, but it has some wonderful deep sky objects in it, such as, well, the Rosette Nebula, Hubble's Variable Nebula, the Christmas Tree Cluster, and so on. So the Rosette Nebula, you'll see there, it also has 3 NGC designations, 2237, 2238, and 2246. The reason it has so many is because it's such a large object that it was kind of different parts of it were observed at different times, and it was believed that they were individual objects. And you can see by the size there, it's actually around 80 minutes by 60 minutes. So that's, so remember 60 minutes is a degree. So for reference, the full moon is about half a degree. So you got to imagine that this object in the sky, you know how big the full moon looks. This object is essentially as big as 2 moons by 2 moons. So it's a truly huge object. And to see it, you need a very wide field of view. So that's a key to observing it. The other key to observing it is you need dark skies. A total waste of time under a suburban sky. you will not see the nebula, even with a filter. So you must be under a dark sky. And the other thing is, even under a dark sky, it is rather faint. So this is one of those objects where even with a fairly large telescope, excuse me, it's much better to use a nebula filter. In particular, for this one, an oxygen-3 gives it a very, very strong response. So looking at the rosette through the eyepiece, first thing that will strike you, you'll know you're in the right region of the sky when you see two chains of stars, and they'll kind of be in two curves facing each other like that. You can see those curved lines of stars in the middle of that photo. So that's actually a cluster called NGC 2234. So those stars are very, very new, only a couple of million years old, and they were actually formed in the nebula that you see around it. And in fact, it was those stars, the pressure from the formation of those stars, which created the hole inside the nebula. So if you're looking under a city sky, you can still observe those stars, but you won't see the nebula. If you're under a dark sky using the filter surrounding that, you will see a reef of dark, cloudy looking material. So that sketch at the bottom there by Stephen O'Meara gives you an impression of what you can kind of see through the eyepiece. So you'll see like a very large donut. And you can also see, with a filter in particular, under a dark sky, you can see a lot of those dark streaks running through the nebula, like you see in that photo. So it's a really impressive sight when everything comes together. So to find it in the sky, like we saw before, unfortunately Monoceros itself is a very faint constellation, but fortunately it's quite near Orion. So what I'd recommend you do is either use GoTo, that would be a simple way of finding it. Otherwise, what you can do is you can start at Betelgeuse and then move your way across to the right until you find that first star in Monoceros, just at the edge of the Telrad circle, and then you should find the Rosette Nebula a little bit below that. And again, you'll know you're in the right spot because you'll see that very bright stars, and there'll be two chains that kind of look like that. And then if you look carefully under a dark sky, you should start to see the nebula forming. Put a filter in and it should really pop out. Okay, well that's the end of this month's presentation. I hope you found it interesting and it will be useful for you. Hopefully you'll get some nice weather wherever you are, and when you do, please get those telescopes and binoculars out in the field where they belong. So until next time, clear skies, good viewing, and see you soon.